Alright, this video is going to be the first in a series showing you how to create what is probably the simplest form of a physics engine that you can make. We're going to make this physics engine animate two-dimensional objects, and we're going to be using Python 3, and we're going to use Turtle Graphics because Turtle Graphics is a nice way to start learning about graphics. It's not the best program to do large graphical applications in. If you were doing something like that, you might want to check out Pygame at pygame.org. All of the things we're going to learn about today are applicable. You would have to just transfer them over to the Pygame APIs. So first of all, let's what are we talking about, right? So let's run a version of this program and see what we should end up with. So something like this. So when I say physics engines, we are basically trying to model certain properties of physics, some subset of properties of physics that occur in the natural world, and we can adjust the physics. So in this example, we have the physics that we're modeling here. We have a concept of velocity, and position, and velocity changes the position over time, right? So you have an x and y position for each one of these circles moving around the screen, and they also have a direction, right? And as soon as a wall is hit, we have a collision, and that's the physical properties of an elastic collision. Okay, so there's a whole lot more physics we could add to this, but we're trying to make this as simple as possible, and this is the smallest amount of physics you can have to really do something that's minimally interesting, right? So with this physics engine, you could sort of start creating the game Pong if you wanted to, right? So let's get started. Let's open up our Atom text editor, and I'm going to create a new file, and we're going to call it part1.py. Alright, so the first thing we need to do is, if you don't have any experience with Turtle Graphics, you might want to watch a couple of my other videos first about that. But we're going to need to import some libraries. So we have import turtle. That is our Turtle Graphics library. We're going to eventually need to calculate some random numbers. So we're going to import the random library. And then we're also going to make use of the time library. Okay. So if you've seen my other videos on Turtle Graphics, there's a little bit of setup we need to do to start up. If you're going to be generating random colors, it might be a good idea to use color mode 255. It means you can specify a color with RGB numbers from 0 to 255, 3 different values. The first one would be red, the second one would be green, and the third one would be the amount of blue, right? So we're going to use this color mode so we can select random integers between 0 and 255 and create random colors. We saw all the circles on the animation had different colors, and we can generate those randomly. Okay, so that's that. The next thing we need to do is we need to set up the screen properties. So you can get the screen with turtle from turtle.screen. Right, so this, we're calling it like a function, but it has a capital letter, so that generally means by convention in Python that this is a class. This is a special type of class called a singleton, because normally when you instantiate a class, you get one object and you can create several of those objects. With a singleton, when you instantiate the class, you always get the same object. There's a single object, which is why it's called a singleton. And that makes sense. If you have multiple turtles on the screen, they're all sharing one screen. They don't have their own individual screens, so that's why that was used in this case. All right, next we need to figure out what the dimensions of our canvas should be. All right, so we might want to set up some constant variables here. Now when I say constant variables, that might sound like an oxymoron, but basically what this allows us to do is just specify some variables that we don't ever intend to change within the running of the program, right? Now we might change it between runnings of the program, right? So I want to specify a screen size here. So I might say the width of the screen should be 640, and then the height of the screen might be 480. Okay. My spelling right. So these are constant variables. When we run this program, throughout the course of running the program, we're never going to change these values. So that's why they're called constant. Now they are variables in terms of the definition of the syntax of the language, and we can change them between execution of the code, right? So if I decide I want to a bigger screen next time I run it, I can adjust it and then run the program again. But throughout the course of running the program one time, these values are constant. They will not change. You'll set them once and leave them alone. All right. So the width and the height are going to give us the two variables that we need to set up the screen size. So here we can say screen size, and in Turtle Graphics you pass in the width and the height. Right, and that specifies the screen size, specifies the canvas size that the turtle can actually draw on. And then there's another property here, screen.setup, and this is has to do with the window size. So we'll say something like width, and we add a little bit of extra here to account for the borders of the window. And this basically we'll set it up so the screen size is just a little bit bigger than this, than our width and height settings, and if it's a little bit bigger, then we won't have scroll bars appear. All right, so I'll show you the difference between both of those. And again, we're gonna add just a little bit of wiggle room on each one. All right, and then we want to create our turtle. So I call mine Don. You can call it whatever you want. That's just a variable name. And here we are creating a turtle object. Now again, we're calling this like it's a function, right? You notice the left and right parentheses. So that's the calling syntax. But we have a capital letter. So this tells us that we are creating an object here. So what's getting stored is an object. So Don is a variable that's actually just storing a memory location, memory address, and at that memory address the data that is this turtle is being stored. Okay, so we create one of these turtle objects, and this one is not a singleton. I can create several different turtle objects if I want. So in this case I just want one, though. Most of the stuff we do you only ever need one. And then also, because this is an animation, at this point we should know a little bit about turtle graphics, so we don't really need to see the turtle on the screen. So I'm gonna hide him. But and then at the very end, I'll add that hide in a second. At the very end, we say turtle.done. Okay. Now turtle, again, this is the package that we imported, right? So attached to this package, this library, there is it's named turtle, and there are different classes and functions and variables or attributes associated with this package, right? So one of them is turtle.done, and this basically just keeps the window open. All right, so let's run this. Python 3 part 1. Okay, and you'll see a window like this. All right, that is my turtle in the middle. He's got a direction. He's a little triangle. And for everything we're going to do, we don't really need to see the turtle. The turtle is useful when learning about how the computer draws things. If you've seen some of my other videos, you'll actually watch the turtle animate as he draws things. So we are past that stage, and we actually don't want to see the turtle. We just want to see what he's drawn. So we're going to hide the turtle, and we do that with don.hide turtle. All right, and I'm going to run that again. I need to close the window. All right, so the turtle is gone. We have the window. We have no scroll bars. If I were to resize, we see the scroll bars appear, right? So that's why we had to add that little extra wiggle room so they don't show up. All right, next thing we need to do is, based on this width and height, it might be convenient to create a few more constant variables that are the minimum value of x, the maximum value of x, and the minimum value of y and maximum value of y for the screen size. Okay, so looking at this with Python 3 Turtle Graphics, we have a coordinate system at play here, and it's a classic Cartesian plane where you have the coordinate 0, 0 is this spot in the middle. As you add positive values of x, you move to the right of the screen, and as you add positive values of y, you move up. Right? Negative values of y go down, negative values of x go to the left. Okay, so what we want to do is we want to define basically what is this line here, right? This vertical line, that's the minimum x value we can have. And then what is this line? That's the maximum x value. Here is the minimum y value, right? And this would be the maximum y value. So how can we calculate that? Well, we know the width and height, and so we can calculate the minimum x. So minimum x is going to equal half of the width divided by 2, but it's going to be negative. Right? Negative width divided by 2. And if we look at our window here, if we know the width is 640, right? 640 pixels, right? Half of that is 320, right? So if 0 is here, the negative 320 would be here, and then positive 320 would be over here. And this might be off by 1 pixel on one side or the other, but that's not really that important. Okay, so the minimum x is going to be the width divided by 2, and then the maximum x, so this is the negative width divided by 2, and then the maximum x is width divided by 2. All right, then we do the same thing for y. The minimum y is going to be the negative of the height divided by 2, and then the maximum x, or maximum of y, is going to be the height divided by 2, but positive this time. Okay, so the minimums, of course, are always negative, and then the maximums are positive. So these variables are actually constant variables. Again, we're not going to change these values. We set them once, and they're going to remain the same throughout the course of the running of a single run of the program. That's why we put them in capital letters too. That's by convention. So if you see something in capital letters, the idea is that variable should have only been set once, and it will never be touched again. Okay, so there's our constants. The next thing we want to do is we want to let's make a function to draw a rectangle, okay? Because as we animate things, we're going to have to draw a background and then draw circles on top of that background. And then we draw another background and draw circles on top of that. Okay, so to do that, let's create a function here, and we'll call this draw rectangle. And to draw a rectangle, I'm going to need an x position, a y position, a width and height, and then I might want a color, right? So, assuming I have all of this, right, what do I need to do? I need to reference Don, my turtle. Actually, this needs to be, I'm moving this down underneath because I have to define Don first, because I'm going to reference Don in this function. So I have my turtle, Don, and Don needs to bring his pin up so he doesn't draw when I move him. I need to move Don, Don.goTo. So where do I want to go to? Well, the x and y coordinates, where do we want the x and y coordinates of the rectangle to be anchored? Right. So what I mean by that, if I say I have a rectangle and I want to draw at the coordinates 0, 0, is 0, 0 the top left of the rectangle? Is 0, 0 the bottom left? Is 0, 0 the center of the rectangle? Right. So usually when you're drawing something, you're probably going to want the anchor point to be in the middle of that object, right? So we have an x and y coordinate here. And I will probably want to go to x comma y. So that would put my turtle at in the very middle. So if I gave it a 0, 0, my rectangle would be centered around that point. But really, I need my turtle to start at one of the corners, and then I need to draw the rectangle from one of the corners. Okay, so we have to do a little bit of math here to figure that out. We want to say Don.pin down. So we want him to draw now. And so we can say Don dot the initial starting point is if we have the width, right, x and y are the center, we have to go x and then subtract half of the width divided by 2, right? So if we have a rectangle, width divided by 2 is going to take us to the left. So whatever the x value is, if it's 0, 0, and we say we want a 100 by 200 rectangle, then we have to start at the x position, 0 minus the width divided by 2, and then y, and we can also start at minus height divided by 2. And all that's going to do is take us to one of the corners. If I'm drawing a rectangle in here, I specify the center as 0, 0. If I subtract the width divided by 2, I'm subtracting half of the width, which brings me to here, and then half of the height, which brings me to here. So then I'm going to want to draw my rectangle like this. Okay, so to do that, we put the pin down. We need to set the color, Don dot fill color, and we're going to say that fill color is whatever's passed into our function here. We're going to say Don dot pen size. We'll just have 1 pixel. We're going to say Don dot pen color is the same color as the fill color. So we basically don't want an outline. All right, and then at this point we need to set or have Don, draw lines from the 4 corners of the rectangle, right? So we say Don dot, and we're going to do go to. Now his pen is down now, so he's going to be drawing lines when we go to a go to statement. So we're starting here, right? And it's basically the same x value, or we actually want to go to x plus the width divided by 2, right? So if we were down at the bottom left of the corner of the rectangle, this is now going to move the x to the right, right? And then we'll keep the same y. So that's y minus h divided by 2. Okay, and then we can duplicate this line, and the only change here, we're going to keep the same y position, or the same x position this time, and we're going to change the y position. So if our rectangle is here, right, we started out down here, we moved to the right, right? The x value went from x minus the width divided by 2 to x plus the width divided by 2. So that's going from the bottom left to the bottom right. And now we want to go from the bottom right up. So we're going to be keeping that x value the same, but the y value now is going to go in the positive direction, right? So then once we're here, we need to keep the y value the same and move back to our x minus w divided by 2. So we'll duplicate this line and change this back to a minus. And then where do we end up? Well, where we started, right? So I can duplicate this line. We're drawing this line now, right? If this whole thing is the rectangle where I'm outlining with my mouse, right? And we're up here in the corner, and we need to keep the x value the same as it was in the last one, but now we're moving y down. So that means we subtract 9 divided by 2. All right, so that should draw a rectangle, but we also want to fill it in. So we say Don dot begin fill, And then at the end, we say done.endFill. Now, it's very important whenever you have a begin fill that you have an end fill, and you only have one of each. All right. Otherwise, you can get into situations where the program, you think that you will have ended the fill, and you won't have, and then it will be a little confusing. So whenever you're drawing something, make sure, and you're filling it in, make sure there's only one begin fill and one end fill. Okay, so we have this draw rectangle, and now what we can do is actually call this function, right? So this is just the function definition. Here, this is calling that function, so that means this code is going to be executed when we call the function. What values do we want to supply to our rectangle? Well, we can say whatever we want. We can say, let's put this rectangle at 100, 100, and these are pixel values, the numeric pixel values, right? So, and then the width and height, we can say the width can be 200, and then the height can be 100. And then what color? We'll say green. There's a number of different ways we could specify the color, but this should work too. So let's try this out. I need to close my old window. Okay, so that drew it. Let me add a little bit of a delay here, so because Python wants to open it up on my other monitor, so I'm going to delay starting the program until I can move the window over here. So for that, I use the time library. So I'm just putting in a little comment here that says this is where the main program starts. I'm going to say time.sleep. And we just want to sleep for maybe 2.5 seconds, and that should give me time to drag the window over. Okay. All right, so here's 0, 0. Here is 100, 100. And in the bottom left, we started at the x value, which is 100, and we subtracted half of the width to get to here. Then we subtract half of the height to get to here. Now we go from this point and we draw. So we go from this point, the x value is x minus half of the width, all the way over to x plus half of the width, right? X is in the middle. Here is x minus half of the width, right? This is half of the width, and here is x plus half of the width, right? So that's what we're doing when we're drawing this. It looks a little bit strange. It's just a little bit of algebra. It's really not too bad. So hopefully you're following along, with what's going on here with draw a rectangle. So we've made this function to draw our rectangle, and now we can use it whenever we want. So this is going to be very useful for us to draw the background of our animation. Right? So I'm going to create a function that's called draw background. And you can specify a color if you want, and I'm basically going to just draw this rectangle, right? So I'm going to say draw rectangle, but what x value, y value, and width and length are we going to use? Well, for the background of the screen, we've specified these constant values, right? So what I want to use is, I'll say 0, 0, because that's the center of the screen, so that's the center of my rectangle, and I want this rectangle to cover up the entire canvas, the whole space. So for the, I'm sorry, I'm in the wrong spot here. Draw background is what I'm trying to do here. So I want 0, 0 for the x and y coordinates, and that's the center of the rectangle that I'm drawing. And for the width, I want that to be the width of the screen. And for the height, I want that to be the height of my screen. And then color, I'll just pass in whatever color I get from this function. Okay, so in this main program now, I can get rid of this draw rectangle. And call it instead draw background. Okay, so draw background is just a function. You pass in a color. Draw background calls the draw rectangle function we just made, sets the position at 0, the width, and the height, and then whatever color. So now our entire canvas should be green whenever we call draw a background. All right, and we can close this. Height. Oh, spelled height. There we go. Okay, now we still do see the turtle animating, okay? Now we don't really want that. We don't really want to see the turtle drawing the actual items. We actually want them to show up really, really quickly. So the way you do that is you basically turn off the tracer, okay? So to turn off the tracer, you say turtle.tracer 0, 0, okay? You can look that up in the documentation. I highly recommend anytime you're working with a particular library, especially like Turtle Graphics or something, you open up the official documentation. You can usually find it just by typing in the search engine Python 3 Turtle documentation, whatever the name of the library is, and it usually pops up first. So this turns off the animation to the actual part of the animation that you see when the turtle is actually drawing. Right, so we see Turtle Graphics is nice because it shows you how the computer draws things, but really the computer's much faster than that. Right, so Turtle is more of a learning tool. If we want to turn that off and actually draw things as fast as the computer can draw them, we have to use turtle.tracer and use these two values. So you can look that up in the documentation to see what that does. But now, since we've turned the tracer off, we have to specifically tell Turtle when to update. Okay, so this is when does the turtle actually draw the things that you've told it to draw, right? And let's run it one more time. All right, and so it just drew that right away. It waited the 2.5 seconds and then drew something right away. All right, so we have almost enough to start animating something. All right, so what we want to do is let's draw a circle. Let's see. We want to put all of this in a loop. Okay, so the idea behind of animation is we have what's called an animation loop. Okay, the process here is each time through the loop we do a certain number of things. The first thing is we cover all of the old drawings with the new background. Okay, so we can make this whatever color we want. We'll make the background black, and then each time through the loop, drawing black background, that's going to cover up all the old items. All right. Then what we want to do is draw all the new items, right? We're going to need to have a while loop here, while true. And the steps are as follows. We want to draw the background. Then we want to update the positions. Okay, so what do I mean by update positions? Well, we're trying to show the illusion of movement by drawing a background and then drawing a circle, but that circle doesn't really move. It just stays there, and we pause the screen for just a second. So our eye registers that the circle is there. Then we update the positions, and we draw the background again, right? And so that covers up all the old circles, and then we update the positions and get the new locations, and then we draw the circles in their new positions. Okay, so we'll see what this means. I'm going to actually put the update positions up here. So then you'll update the positions, draw the background, and then draw the actors. And in animation, the actor is just anything that's moving, right? So in this case, we have extremely simple actors. They're just going to be circles. And they're the only physical properties they have that makes this a physics engine is they have velocity, and that basically each time through the loop, we're going to update their position based on their velocity. All right, and so they'll be in a new location. And then the other portion of the physics that we're going to have is the idea of an inelastic collision, right? So we need to draw the actors. So what does that entail? Well, let's just start with a simple ball. All right, so we could say we're going to need to say Don dot pin up, Don dot go to, and we're going to need some x and y value, right? So we'll start some x at, we'll say maybe 100, y is maybe negative 100. Then we have, we're going to go to that location, x, y, right? And if you've seen how Turtle Graphics draws a circle, let's just put this at 0, 0 to start with so you can see this. I'll demonstrate this. We go to that location, we say Don.set heading. Heading is the direction that the turtle is facing. We want that to be 0. So 0 is to the east. That's over here. It's in degrees, so that's 0 degrees. 90 would be north, so that would be the turtle facing upwards. 180 would be to the west, and then 270 would be facing south, right? So with this turtle, when we draw a circle, we can say Don dot, let's see, we need all of this stuff. We need pin size, we're going to say is 1, Don dot pin color, we're going to say is black. We might want that white since the background's black. Don dot fill color, I might make this red. And then Don dot pin down, and then Don dot circle. And then that circle is going to be drawn with a particular radius. All right. So what is the radius? We'll say it's 50. So the circle will have a diameter of 100 pixels. All right. And we also need to fill this in. So we say Don dot begin fill. And then after we draw the circle, we say Don dot end fill. Now remember, again, just one of each of those. You begin the fill right before you start drawing, and then end fill will automatically connect the shape that you've drawn and fill it in with a color, whatever the fill color you specified is. Okay, so this is running in a loop. Okay, and when I run this, we're going to see here up at the top on my computer, I have all of the processing cores of my computer up here. So one of these, and it might alternate between them, one of them is going to max out because we're in a loop. We're going through as fast as we possibly can, and we're not giving the computer a break. We're not sleeping inside of this loop, right? So all this stuff here is inside of the while loop. Everything that's indented is inside of our main animation loop. All right, so let's try to run this and see what we get. Okay. Now, you see it's not moving, and that's because we've never updated the position. So we do have a black background. We have a circle with a white outline, and it's filled in red. Right? And if we look up here, we do see that there are some spikes here. We are using more processor than we were before, right? And if you added them all up, it would probably amount to, yeah, see there's a big spike. It would probably amount to 1 processor core maxing out at 100%. Okay, so how can we tell if this is really animating anything? Well, we have to update our positions in this while loop. So how do we want to do that? The simplest way we could do that is just add a number each time. We can say x equals whatever it did before plus 1. And then we can say y equals whatever it did before minus 1. All right, and then we we can run this and see if we get any animation. Okay, now there's a few things to notice there. One is that it starts out really fast and slows down, which is not ideal. Okay, now there's a reason for that. The reason for that is technically all of these things that we're creating, when we're drawing these rectangles and all of these items that are drawn on the canvas, we're not just setting the pixels. There's actual objects in memory that are stored about each one of these lines that we're drawing. Okay, and if we just cover up the background or cover up all of the previously drawn stuff with a background, then those items are still hanging around in memory and still have to be managed. And so Python is still concerned with them and still checking back in on them. And so the more of these we create, the slower and slower and slower Python is at iterating through all of those items, right? So there's a way to get around this, and that's by destroying all of the items we created. Because when you think about it in an animation, you never need any of the items from the previous frame. We're going to draw a background, and then we're going to draw all new items. So all the actors in the background from the previous frame, they aren't needed, right? So the way you can destroy all those items is you can specify your turtle and just say clear, and that deletes all of those items. So Python and Turtle Graphics don't have to manage those items anymore. So any of the items that were drawn with this turtle, you call that turtle and then clear, and it will remove those. So now we should see the circle go a little bit faster. It should go a constant speed, right? See, that was much better. It went a constant speed. Okay, so we have basic animation. We could change this, right? We could change this to go, this is going 1 pixel per frame. Now, one of the biggest problems with this, what we've set up, this is basic animation, but what's happening is we really don't know how fast this thing is going to go. Each time through this loop, we're adding 1 pixel and drawing it again, but it depends on a lot of factors, how fast this code runs, right? We don't know if I have this is a pretty nice computer and it's going to go faster than a lot of other computers. If I have an older computer, then even though I'm just adding 1 pixel or subtracting 1 pixel from the Y value, each time the speed is actually dependent on how fast this loop runs, right? So that's not ideal. Ideally, it wouldn't matter what machine you ran this code on, there would still be, the object would move at the same speed, the same perceived speed. So in the next video, what we're going to have to do to get around that is we're going to have to start calculating the change in time between each one of these frames, right? So each time through this while loop is generating a frame. Okay, so we want to, this generates a frame each time through the animation loop. All right, so this is the bare bones of getting started with animation and the bare bones of working with the physics engine. Now we haven't added anything cool like inelastic collisions off the wall. We also haven't added different velocities. Right now we just have it's moving, and that's about it. It's the bare minimum of animation. So in the next videos, we're going to start adding pieces that will make it more like the complete goal that we saw. And I'll run that for you one more time. So this, again, is the goal that we're trying to work to. Something like this. Okay, and the speed of these circles will be the same on any machine that you run it on, because of the way we code it. So the way you code things up matters. There's lots of ways to solve problems, but depending on if this program is going to be run by multiple people, it probably needs to have the same speed for each one of these circles, right? If it's not, it doesn't matter so much, right? But these are important things to think about as you code up solutions to problems. All right, so this is part 1 of the simplest physics engine you can make using Turtle Graphics on Python 3.